perpendicular lines. What does it mean when we say graphs or lines are perpendicular? I know you guys have heard this word before. What does it mean? What does perpendicular mean? And yes, guys, I'm still looking for my pen. But in the meantime, I want you guys to tell me what perpendicular means. Straight lines from up to down? Not necessarily. Does anyone have another suggestion? Those would be parallel lines, Leachidwe. And yes, Entle, they are lines that cross or meet at a 90-degree angle. So that's what we'll be speaking about today. So if you look here, I have two lines, XY, which is a vertical line, and AB, which is my horizontal line, which meet at 90 degrees. Now, one thing to be very careful about is you never assume that lines are perpendicular, okay? You have to at least know that angle or be given that little block over there at the bottom. What does that block mean? What does it mean? We also dealt with it in the previous lesson. Yes, that's correct. It means the angle is 90 degrees. So never assume, okay? Never, never, never assume that lines are perpendicular unless you get that little block or you get an actual 90-degree written in numbers. Or the third option is if you have a shape like a triangle and you know your other two angles, you can work it out, right? You can figure it out and then you'll know that it is 90 degrees. Now, this is the symbol that we use to write or speak of perpendicular lines in math. Have you guys ever heard people say mathematics is its own language as well? We have our own symbols that mean specific special things. Okay, so that upside down T, what looks like an upside down T, that is our symbol for perpendicular lines. And today we're going to practice using it, right? So that we get used to it when we see it in a test. Imagine seeing that in a test and you have no idea what it means. And it is important to know when to use the 90 degrees. Okay, guys, I found my pen. Good news. Okay, let me sit properly and then we can get going properly. There we go. Hello, guys. All right, so as I was saying, the symbol upside down T means they are perpendicular. So if you look at an example here, this says line AB is perpendicular to CD. And for this example that we have here, we would say line AB is perpendicular to line XY. Now, bring your attention back to the whole capital letter story. This is the name of a line, right? It's telling you where the line starts and ends at A and to B. And so is this. So we always use capital letters. Can anyone recall when we use small letters? We spoke about it in the previous lesson. When do we use the small letters? Capital letters are for names of lines, and small letters are for names of variables, yes. But where do we usually use those variables? Nice, in an angle. Okay. So if you have multiple A's and B's, be careful and make sure you're using the correct one, either the one for the line or the one for the angle. Now, I told you guys you can never assume that lines are perpendicular, right? I gave you 3 methods to figure that out, but there is a fourth one, which is what we're going to be dealing with today. And that is by using the gradients of those lines. Okay? What is the gradient again? We did do it when we did graphs earlier on in this term, yes. In about the second week of this term, we spoke about the gradient. There we go. It is the slope or steepness of the graph. So this would be a slope or steepness? How steep is the graph? Okay, so in the formula for a straight line, y is equal to mx plus c, which of those variables represent the gradient or the slope? Do we remember? That would be m. Right, guys, beautiful. So it's this one. The coefficient of x is that one. So if you have two graphs, right, and you have the gradients of those two graphs, you first need to find the product. What does product mean? Which operation talks about product? Multiplication, that is true. The product of those gradients, if it is equal to -1, then those gradients are, or those lines rather, are perpendicular. Okay, so that's a fourth method that we can use to find out if lines or graphs are perpendicular. So here is just a notation that we use where you say m1 or gradient 1 times gradient 2 is equal to -1. Now, with that information, I want us to look at these 7 graphs over here, and I want you guys to find a pair or 2 or 3 or however many there are of lines that are perpendicular. Does anyone have a suggestion of which 2 we can try or start off with? Which 2 can we try or start off with to check whether or not they are perpendicular? Okay, Alice says number 1 and number... Okay, I have Mavis who says 3, 3, and 7. 3 and 7. Remember, we need a pair, guys. You can't tell me one gradient. You have to tell me 2 of them because we have to multiply them. We have to find the product to check if they are perpendicular. Okay. I'm going to go with 1 and 2 because I want us to see something. I want us to observe something. Okay. Actually, 2 and 3. I'm going to go with 2 and 3. 2 and 3. Okay. That means I'm going to say m of 2 times m of 3, which is -1/3, times -3 over 1, basically. Okay, I hope we all understand that -3 over 1 is the same as -3. Now, we're multiplying two numbers over here, and they are both negative. So what is my answer going to be? If I'm multiplying these two, my answer is going to be positive. That's clue number 1. And then my denominator for the one is the same as my numerator for the other, which means I can cross cancel, right? What is our common factor between 3 and 3? This is the simplest, easiest common factor, 3. And it goes into itself once and once. So my answer will be 1 times 1 in the numerator, which is just 1, over 1 times 1 in the denominator, and that's positive 1. Are those two lines perpendicular? No, they are not. Okay, I got a 1, but I didn't get a -1. But there's some things that this question can help us figure out. The first one is I need to have different symbols in order to get -1. Do you agree? The only way to get a negative answer is if one of the gradients is positive and one of the gradients is negative. So the fact that they were both negative was a clue already that these guys were not perpendicular. Okay, so we're looking for 2 that are negative and positive. Great, we know. And then we got our number though, which is a 1. That tells me that my numerator for the first gradient has to be the same as the denominator for the second gradient. And only then will I get -1. So I see people suggesting let's do number 4 and 5. And I want us to first convert the 0.25 to a fraction, because if this was my class and my test, I would make you guys use no calculators. I know it's easy to use calculators here, but no calculators. How do we convert 0.25 to a fraction? I'm going to do it up here quickly. It is 25 over what? You see why I say no calculators? The brains are off. 25 over 100. There we go. And then what is our common factor between 25 and 100? Our highest common factor. That would be 25. It goes into itself once and into 100. How many times? 4 times. So this is the same as a quarter. Great, we've established that. Now let's do the multiplication. So it's going to be M4 times M5. And that is 1 over 4, since we've already established that, times M5, which is negative 4 over 1. Great. Now I have a positive and a negative. So what will my answer be? Positive and a negative. That's going to give me a negative. And what is a quarter times 4? If you want to do the whole common factor thing, you're going to do that. This is once. My answer is negative 1. So are gradients 4 and 5 perpendicular, or lines rather? Are they perpendicular? Yes, they are. So these are perpendicular. Great. And then there's one other pair that I've seen someone type in the chat. I think it was Sinyani. Yes, it was Sinyani. Sinyani told us that gradient 1 is also perpendicular to gradient 7, because let's see, M1 times M7. Okay, I have a positive and I have a negative, so the symbol part is sorted, right? And then my denominator, which is 2, is the same as the numerator for the other one. Okay, and then if we check 2 and 2, that is our common factor, and I get a negative. What is a half times negative 2? 1 over 2 times negative 2 over 1. 1 over 2 times negative 2 over 1. That would be a negative 1. So are these two lines perpendicular? Yes, they are indeed perpendicular. Is there any other pair of lines here that are perpendicular? Is there any other pair besides those ones that we have gotten out the way? No. So we are done. Can I get a thumbs up, thumbs down? Wonderful. Okay, I don't see any thumbs down, so I'm going to assume everyone is good. 2 and 6. No, because 0,2 is 20 over 100, which is 1 over 5. Okay, that's 1 over 5. So already my denominators and numerators are not corresponding. Okay, guys, I think we can move on. Now, the second way that I spoke about is to find the gradients. But now, in the first one, we were given the gradients, okay? When would we be given the gradients? If we are given the equations of the graph. So if they say y is equal to negative 2x plus 1, you just look at the graph, okay? But the second option is we are given coordinates. Now, I want you guys to tell me, what can we do with those coordinates to help what we are doing here? What can we do with those coordinates? What do we do with these coordinates, guys? I have two coordinates here. I have a line 1 and a line 2, and I have coordinates for each. So what do we need to do with these coordinates in order to figure out whether these lines are perpendicular? Let's hear. Nicely, Achille, we need to find the gradient. So I'm going to find the gradient of line 1. I'm going to write it over here. M of line 1 is the y of coordinate B minus the y of coordinate A over the x of coordinate B minus the x of coordinate A. Okay, if you wrote it the other way around, if you said A minus B, I promise you're going to get the same answer. The only condition that I had was the same coordinate must come first, and the same one must be lost. Okay, that's the only condition. Now, what is the y coordinate for point B? My y coordinate for point B, that will be -4, that's true, minus my y coordinate for point A, -1. I'm going to emphasize this again, okay? The first minus is the one that is in the sum. The second minus is the one that is in the coordinates. I almost highlighted the wrong one. Okay. Oh, thank you. Oh, Ziva's being so cute. And then let's look at the x coordinates. What is the x coordinates of point B? That would be a -1 minus my x coordinate for point A, 0. Now tell me what this minus is going to do. What's going to happen there? That would be a positive. Wonderful. Now let's get working. That means I have -4 plus 1. What's -4 plus 1? -3 over -1 minus 0 over -1. And what is -3 divided by -1? That will be a +3. Great. We have our first gradient, +3, sorted. Now we need the gradient for line 2, which is the y coordinate for point E minus the y coordinate for point F over the x coordinates of point E minus the x coordinates of point F. Great. What is my y coordinate for E? That is -2 minus y coordinate for F, -3. Great. Divided by my x coordinate for E, which is a 0, minus x coordinate for F. Nice, guys. You guys are going fast. Great. Again, I have this minus. What's going to happen with these two negatives? They give me a positive. So then I have a -2 plus 3. What's -2 plus 3? Check again. Ooh, algebra. Nope, integers. -2 plus 3. That is a +1 indeed. Over 0 minus 3, which is -3. Great. Now, the question was not find the gradients. The question was, are the lines perpendicular? So what do I need to do with these two gradients that I have now found? I have to do what with them? Multiply them. Great. So M1, gradient 1 times gradient 2. And before I even work it out, are these two lines perpendicular? I know you guys can see it already. Nice. Yes, they are. A positive and a negative gives me a negative. And 3 times -1/3 is equal to 3 times -1/3 is equal to 1. And my answer is yes, they are perpendicular. Nice, guys. This is nice marks in a test, right? If you were given this, this would carry quite a bit of marks in a test. Can I get a thumbs up, thumbs down? Did we understand this question? Wonderful, wonderful, lovelies. I like it a lot. Okay, now we have another one that I'm going to challenge you guys to do. And whoever has the answer first for my gradient of line 1 and gradient of line 2, please send it in the chat. Everyone else, you can do it with me, okay? If you prefer to do it with me, that is fine. But if you want to take part in the fastest fingers first, then let's do so. Okay, M of 1 equals the y coordinate of point A minus the y coordinate of point B over the x coordinate of point A minus the x coordinate of point B. There we go. Now let's look. What is the, y coordinate of point A? Y coordinate of point A. Everyone is doing the question on their own. They're doing fastest figures first. Okay. My y coordinate for point A would be A3 minus the y coordinate of point B, which is a 4, divided by the x coordinate of point A, which is 2, minus the x of B, which is 0. Now, we don't have any simplifying over here, so I'm talking about symbols, like there's no plus, plus, or minus, plus. It's just a sum. So 3 minus 4 would give me a negative 1 over 2 minus 0, which is 2. So we have gradient of M1, and I think we got that. I didn't check to see if you got it before I did. Okay, and now we move on to gradient of point 2, of line 2. Gradient of line 2. So that would be the y coordinates of point F minus the y coordinates of point E, divided by the x coordinates of point F minus the x coordinates of point E. And this will give us, let's check, y coordinates of F is 7 minus y coordinates of E is 3. So 7 minus 3 over x coordinate of F, which is a 3, minus the x coordinate of E, which is a 1. Again, we don't have the symbols and simplifying thing. So we have a 7 minus 3, which is a 4, divided by 3 minus 1, which is 2, and that is 2. And Senyane, I'm guessing that's what you had written in the first place. I was wondering what that 2 was for or where it came from. But now I know. Now, are these two lines perpendicular? Obviously, I'm going to do the calculation, but what do we think in the chat? What do we think in the chat? Interesting responses. Interesting responses. A negative times a positive. What is that going to give us? A negative. And then what is my common factor between 2 and 2? It's just 2, right? So 2 goes into itself once. In my numerator, I have a 1 times 1, which is a 1, over 1 times 1, which is a 1, and this is negative 1. So are these two lines perpendicular? Yes. Those who said they are perpendicular before you did the calculation, tell me what the two conditions are that you checked. Let's revise the two conditions. Firstly, what do the gradients need to look like? What do the gradients need to look? The more I read my perpendicular word, the more I'm like, is that spelled correctly? Let's just hope, eh? Yes. Firstly, one gradient has to be positive, one has to be negative. And if you check here, M1 was negative, M2 is positive. First condition met. Second condition. What is my second condition? My second condition, the numbers. What about the numbers, lovelies? Talk about my numerator and the denominator. The numerator of one number has to be the same as the denominator of the other. This is what I'm talking about, okay? Here, I have a 2 as the denominator, and here I have it as the numerator. Now, if that's true, you're going to get an answer of negative 1, which means these lines are perpendicular. Can I get a thumbs up, thumbs down? Thumbs up, thumbs down. Wonderful. You guys are so enthusiastic when we're doing geometry. I like it. I like it a lot. All right. The brain break is here. It's a bit early, but it's fine because you guys are fast. Overachievers. Who's going to talk to me for the brain break? Who's going to be talking to me for the brain break? Okay, I see 2 hands. Let me allow you guys to unmute. and open Q. Sing, Annie. You're the first one on the list. Are you ready?
Yes, ma'am. Hello.
Hello. Sing, Annie, would you rather live in the same house for all of your life, like never move ever, or have to move every single day?
Same house.
Thanks. Same.
Cause moving every
Same.
day, so it's so inconveniencing.
Guys, imagine you come from school and you have to pack boxes. Oh my goodness.
Exactly. At a point, you're just gonna take three things everywhere you move.
Oh my goodness, guys. I would actually not unpack. I would just keep them in the box. If I know
Yes.
I'm moving tomorrow,
Yeah. There's no point.
yeah, I would just keep them in the box. What do you say in the chat, guys? I only have 3 responses. And everyone says same house. Is there anyone who says they'd rather move? I'm very curious to know if anyone is saying it is annoying. It is annoying to move every day. But some people would think, oh my god, think of the house you're living in right now, guys. Like, would you make it if you had to live in that house forever and ever and ever and ever and ever and ever and ever and ever? What do you think? Depends on the house, right? That's what I'm saying. Think of where you're currently living. Yes, you do get. Oh, you mean when you're staying? No, when you're staying, no, you don't get a choice. But if you're gonna move, they allow you to choose where you go. That's a nice condition that I've just added now. So you could decide to live in a penthouse today, and tomorrow you're gonna go live at the beach house, and the next day. I knew that's where this was going. Guys, watch how the tables are turning. People want to live in penthouses and beach houses. You guys are not loyal. Hi, hi, hi. Wow. Okay, guys, let's look at the second one. Would you rather shop online or in the shop? Butlali, this one is yours.
Hi, ma'am.
Hello. What do you say?
Ish, ma'am, I think in store is better because, ma'am, well, ma'am, I do agree for some people online because I also don't like socializing. But, ma'am, in store, ma'am, it reduces like fees of delivery or shipping and all
Me, I
that.
don't care, guys. I'm such an online shopper. Oh my goodness.
But,
I
ma'am, it's
don't
also
like
a nice
shop.
experience because you get to like, hold the shopping bags, ma'am. Contents, ma'am, even though you're not even buying those things, you can trick yourself
No,
buying it.
guys, I would not shop in store. I cannot. I cannot. I would rather measure myself, guys. I take out a measuring tape and I measure my foot to see if the shoe will fit it. I will do anything not to go to a shop. Guys, I even buy groceries online. That's how far I am. I even buy groceries. If I think, oh, I need bread, then I like look around and be like, okay, if I'm gonna pay for delivery fee, might as well buy bread and dishwashing soap and Coke and this and that, so that at least I don't feel bad about spending that. But Shem, yes, let's go 60-60. Me, I shop online, guys. I don't play like that with being in. If I'm not at work, I'm at home. Even my car knows. Even my car knows. It knows. We go up there, that road, and then we go back down that road and park. Next up, guys, would you rather wear a puffer jacket on a hot summer day or a tank top on a cold winter day? This one, this one is, this one is a little bit much. Either wearing a puffer jacket on a very hot summer day or a tank top on a cold winter day. I don't know how I feel about this one, guys. I don't know how I feel about this one. Guys, think about the sweating. Oh. No, you're not allowed to remove it. You must wear it and commit to it. You must put it on. I also hate Genko, but I also hate sweating, guys. And you know how puffer jackets are? You start being slippery because you guys, that's too much information. But you guys know what I'm saying. You start feeling slippery and because you're sweating and it's like zip, zip, zip. Alright, guys. Next one, would you rather find someone's hair or someone's nail in your food? Not artificial nail, a nail that broke off of their finger. What do we say, guys? Everyone's like, hair is fine. Hair is okay. Guys, think of nails and hands. And this person probably opened their car door and a million other doors. And there's stuff underneath their nails. And it's in your food. No, Entle, let's say you first took a bite and then you were like, what is that? And you took it out. Would you rather be looking at a hair or a nail? Yo, guys, me, I would say hey. Nail is a little bit traumatizing, to be honest. It feels traumatic. It feels traumatic. Next, would you rather store all of your food in your cheeks or in a hump on your back? What do you say, guys? Alice? Yes, you may unmute, Alice. Guys, please think long term. In your cheeks, you can only store so much. If I'm gonna store food on me, it's gonna be enough. Okay, for all that trauma, I best have enough. Only 2 people responded, guys. What does everyone else say? You will look like a squirrel, guys, but there's saliva in cheeks. Did you guys think of that? Your food will be soggy. Okay. All right, guys. Are we ready to get going? I'm moving. I don't care. It's fine. Imagine how you will look with stuff in your cheeks. And on top of that, you must eat soggy food. Nope. I'm sorry. I won't be able to do it. I'm picking a battle here. I am picking a battle. Okay, guys, let us continue. So let's complete the sentence to defrost our brains again. If 2 lines are perpendicular, then the product of their what? The product of their what? The product of, Aibo, guys, what were we multiplying this whole time? Gradients. There we go. The product of their gradients is equal to -1. -1. All right. Are you with me? I think you can just minimize what you are looking at and then you'll find my screen, okay? Otherwise, it's going to disrupt the lesson because sometimes it doesn't even want to share. Imagine I stop sharing and it doesn't want to come back up. Oh my goodness. Okay. Now, here's another way. So we have done the way where you have an equation and you just look at the gradient. And then we've done one where you get coordinates and you find the gradients. Now we have a graph. What are we going to do with these 2 graphs, guys? What are we going to do with these 2 graphs? I'm going to name this one F. I'm going to name this one G. Well, they're already plotted. Like we can see that we have 2 graphs. But I want to know if these 2 graphs are perpendicular. So what do I need from these graphs in order to know that? What do we need from these 2 graphs in order to know whether or not they're perpendicular? Come, guys, I know you know the answer. No, we can't find an angle, right? There we go. We find the gradients. Nice, which means we need coordinates. Now, can we look at graph F, which is this one? This guy over here. Graph F. Can anyone find two coordinates for me, please, on graph F? Ones that you are sure of. Not estimating, ones that you are 100% sure of. Can we find any two coordinates on graph F? Let's see. 0, 2. Beautiful. That will be my point A in this case. Let's find another one. Because to find the gradient, we need two of them, right? So let's find another one. Entle has given us 0, 2. Negative 5 is over here, but that's graph G. But if you say negative 1 and 5, that's all the way up there. So it's not negative 1 and 5. That's just a symbol mistake. It's negative 1 and here. Negative 3, guys. Can you see it? So my point A is 0, 2. And my point B is negative 1 with negative 3. Great. Now let's look for the gradient. The m of f is equal to the y of a minus the y of b divided by the x of a minus the x of b. What is my y of a? My y of a, that would be 2 indeed, minus the y of b, which is negative 3. And yes, there are double negatives because of the one in the formula and because of the coordinates. Okay. Divided by the x of a, which is 0, minus the x of b, which is negative 1. What are these negatives going to become? We have 1 in the numerator and the denominator this time. This is going to be a plus, and this is going to be a plus. So then I have 2 plus 3 in my numerator, which will give me a 5 divided by 0 plus 1, which is a 1. And 5 divided by 1 is 5. Wonderful. We have the gradient of f. Now, can I get 2 points on the graph G, please? Can I have two coordinates on the graph G? Yes. 5 and negative 1, which is over there. So I'm going to call this C, and indeed 0, 0. Okay, it goes right through the origin. So let me write where I have a little bit of space. C is the point 5, negative 1, and D is the point 0, 0. Okay. M of G is equal to the y of D minus the y of C divided by the x of D minus the x of C. Okay, y of D is 0 and so is the x. Minus, what is my y of C? My y of C, that would be negative 1. Okay, and then my x of C, my x of C is 5. So then I have this minus minus, which we have established will give us a positive. So my numerator, I have 0 plus 1, which is just the 1, divided by 0 minus 5 in my denominator. That is indeed negative 5. So are these perpendicular before I work it out? Equals negative 1 over 5 times positive 5 over 1. Yes, indeed, they are. A negative and a positive, my answer is negative. And then 1 over 5 times 5 over 1 will give us a negative 1. So these are indeed perpendicular. So you can say the graph of F is perpendicular to the graph of G. Let me zoom out for anyone who wants to take a screenshot. There we go. There we go. Thumbs up, thumbs down on this calculation. We still have one more graph, and then we're going to call it a day. Remember, these are small letters because they're actually Greek letters. They're not the normal. Okay, have you seen when we write fx? This is basically fx. It's not just f. So fx is actually perpendicular to gx. And I'm glad that you pointed that out, okay? Have you guys seen this notation before, fx and gx? That sometimes replaces y in our formula. So instead of saying y is equal to 2x plus 5, we just say fx is equal to 2x plus 5. Okay, and now we have our final one, and I'm going to zoom out because it looks tiny. Let's get coordinates of, I'm going to name them f and g again, f and g. Let's get coordinates on f. Let's get coordinates on f. Coordinates on f. Anybody? Can we see? You remember you can zoom in on your side as well. Okay, Achille says 1 and negative 5. There. Yes, so that's my point A. Thank you. Let's get a second one, please. There we go, Alice. 0 and 2. I almost wrote 0 and 2. Okay, be careful with unmuting. There we go. So this is point B. So my gradient, let's see fastest fingers. Gradient of f, y of b minus y of a over x of b minus the x of a. Okay. I didn't write the coordinates. No wonder I'm confused. B is 0, 2. A is 1, negative 5. Great. Y of b, 2 minus negative 5, which is the y of a, divided by the x of b, which is 0 minus 1. Again, we have our positive over here. So in the numerator, I have 2 plus 5, and 2 plus 5 is 7 over 0 minus 1, which is negative 1. So what's 7 divided by negative 1? Negative 7. Great. Let's move on to gradient of g. Has anyone found points or coordinates for me on g yet? 0, 0 is true, which is point C. And the last one, one more coordinate. One more coordinate, guys. Let's see, negative 8, negative 1. Yes, negative 8, negative 1. Right. Now let's see, this is D. D is negative 8. You just swap them around, Alice. Be careful, okay? So now we don't need the graphs anymore, so I can move to the side. So the M, I already wrote the M. Why am I writing it again? Because my brain is tired. The y of C minus the y of D over the x of C minus the x of D equals, what's the y of C? We have 0 minus negative 8 divided by 0 again minus negative 1. Again, we have this negative, negative, positive, positive. What's 0 plus 8 in the numerator? That is 0 plus 8. Hey, guys, there we go. 8 over 0 plus 1, which is 1, and this is 8. If I multiply these together, am I going to get a perpendicular line? Negative 7 times 8. What's negative 7 times 8? It's definitely not negative 1, né? But what is it? Negative 56. So these are not perpendicular. And this emphasizes my point because if you look at them, this does look like a 90-degree angle, doesn't it? But what did we say? We said you must never assume. Do we get my point, guys? There's for screenshotters. Can I get a final thumbs up, thumbs down?